Good morning, guys. So, based on your feedback from Friday, it looked like we wanted to go into probability for the last few days. So, what we're going to do is we're going to start off with tree diagrams, which are not only useful for probability, they're also useful for combinatorics, which is basically finding like numbers of outcomes and such. Um, so, today's aim is how can we model the different outcomes of a situation. So, suppose you flip the coin 3 times. How many different outcomes would be possible? Explain how you arrived at your answer. So, come back when you're done to see your responses. So, there are 8 different outcomes. So, how did you arrive at this? Well, I used the tree diagram, right? So, I started with my first coin. There are 2 options, heads or tails. From each one of those options, there are 2 more, heads or tails. 2 more, heads or tails. And then from each of those options, there are 2 more, so heads or tails, heads or tails, heads or tails, heads or tails, heads or tails. So all of these outcomes represent the third flip. This is the second flip. This is the first flip. So at the end, you have all these branches. Those are the total number of outcomes. I will explain another way of doing it too. That's a little quicker, but this is a much more visual way. So tree diagrams, they are a tool that we use. We use them in general mathematics, right? But you see it a lot more common in probabilities. It allows us to calculate the number of possible outcomes of an event as well as list these possible outcomes in an organized manner. We call the collective outcomes, right? So all of those 8 outcomes from the do now, we call those the sample space. So now, right, the name tree comes from the branches that spread out from the beginning. In the do now, those 8 branches at the end represented the 8 possible outcomes that could occur if you flip a coin 3 times. So, like, going back to it, right? An outcome could be heads, heads, heads. An outcome could be tails, tails, tails. It could be tails, heads, heads. That's kind of what each step in the tree is representing. So now, guided example, how many outcomes can occur from flipping a coin once and rolling a dice? Come back when you're done. Alright, so how many outcomes? There are 12 possible outcomes. So if you did the tree diagram here, it should look something like this. Now I'm going to tell you a shortcut, right? What you can do is you take the event, right? Flipping a coin. You say there's 2 outcomes there, so 2. You take the second event. How many outcomes there? 6, right? 6-sided dice. So 2 times 6 is also 12. So another way of thinking about it is if you know how many events there are how many outcomes there are per event, you can multiply those across, so to speak. So 2 outcomes from flipping a coin times the 6 outcomes of rolling a dice is 12, and the heads, tails, and 6 on each, so that's 12 outcomes either way. Alright, so for your independent work today, you have this one question. I would like you to really try to make a tree diagram and then determine the probability that the balls are all the same color. So how many of those outcomes have either all white balls, all green balls, or all red balls? Other than that, guys, have a great day. Enjoy.